Hi class, this is Aris Iftikhari, and this is my Teach 1 assignment for HAP823. I'm going to be doing problem number 2 in the Bayesian networks lecture. Problem number 2 states, using Netica, construct a Bayesian probability network model that would predict success with citalopram. You need to include at least 5 variables in your model, and remission or relapse should be considered the end node. We will be using the *D data from previous assignments. Please note that for getting the *D data to work on my computer with Netica, I had to convert the XLSX file to a CSV file, and then had to convert that CSV file to a text file. You may or may not have to follow the same procedure. I don't know. Trial and error is how I figured it out, so you may have to do the same thing. So to obtain Netica, go to norsis.com, click on Downloads, then Netica, then download the executable file and follow directions for installation and usage. It's a fairly simple process, and it doesn't take up much space on your hard drive. Netica is free to use for up to 15 nodes. We will only be using 6 nodes to solve number 2. After installation, you can launch Netica. When launching, you'll be prompted by this window. Leave the field blank where you would normally put a password, and just click limited mode, and you can use Netica in the free version. The following steps will demonstrate how to create the Bayesian probability network in Netica. So to get started, we start a new file, and we click the upper left-hand corner, and then click the Node button on the toolbar, which is a little circle. If you double-click it, it will save as that icon, and then we can enter the nodes, and then we can do the same thing with the connector button, and now connect all the nodes into a network. It's fairly simple, just point and click, sometimes click and drag, and you have to end on the end node here to make the network complete. Now we can set up the nodes. As you can see, we have our network as the way we want, and we can start editing the nodes to load the model. First thing we want to do is save the file. We'll just call it Q2 since it's question 2. Hit save. Now we can start editing the nodes. Double click on the node and the window will pop up where you can enter the name. For our root node, we're going to use post-traumatic stress disorder, which is PTSD. And for the state, we are using yes or no. So yes will be 1 from the data, and click new to add another property of the variable, and then no will be 0. Click OK. And then we'll have to do this for all of the nodes in the network. Let's do it one more time with the second node. For this one, we'll do alcohol. Again, coming from the data set. The yes will be 1. Click new. The no will be 0. And click OK. And then we can do these for the rest. And we'll go from there. So our root variable again was PTSD. Our remaining variables will be alcohol, personality disorder, panic disorder, and obsessive compulsive disorder. The end node will be remission. So after you've entered all the properties for the rest of the nodes, your network will look like this in Netica. And we can start with the simulation of the network by loading the data. As you can see, they're all set to 50 now. That's just the default state before you load any data. So to load the data, we'll go to cases, and then learn, and then incorporate the case file, which for us would be a text file of the *D. The default value here will be 1. Let's just keep it at 1. And after we've loaded that, we go to the little lightning bolt icon on the toolbar, which is the compile the network. And we click that. And now all the probabilities have been loaded into the nodes. and you can see that the network has now been compiled. If you hover over, you can see what the mean and standard deviation is for each node. And if you hover on the connectors, you can also get more information about the network. Now, if you go to the end node and double click, you can generate the table, probability table for this end node. And as you can see, all the variables are listed on the left, and then the probabilities are on the right. Every potential scenario is there for all the variables with yes and no. Okay, that should be it for number 2. It's a fairly simple question in the assignment. Thanks for watching. I apologize for any background scratching, sniffing noises. That was probably my dog. If you have any questions, you should probably ask Dr. Alini. Thanks.